Greetings, grade 5s, you fantastic individuals. Welcome to this Worksheet Cloud grade 5 maths lesson all about multiplication. I'm Mr. T, your math teacher for today. We're going to be looking at multiplication. At Worksheet Cloud, we are all about having fun while we learn, which is why we have instituted a great new feature, the Rewards Hub, where you can earn rewards while you're learning. I don't get it, to be honest, myself. I mean, you're getting a reward for something that's good for you and you should be doing anyway. But there we go. You can earn rewards while you're learning. Rewards such as Nomi Hot Chocolate or possibly even a PlayStation 5. But more about that later. Let's get on to today's maths. So, multiplication. Lesson objectives, what I hope that you'll take away from today. Know about the... Let me start off by saying some of these things sound complicated, but actually, once you see them, you'll probably realize you know them already. So I hope that you are reminded about the multiplicative property of 0 and 1. And know the commutative property of multiplication. You probably already know it, just didn't know it had that fancy name. Tricks with 0 when you're multiplying, that you've seen at least a couple of different ways of multiplying, some strategies, and that you're able to multiply up to 3-digit numbers by 2-digit numbers. And then we'll get in some practice with word problems, because in real life, maths doesn't usually come to us in nice, neat, laid out things. We have to take the maths out of the world around us before we can do it. So good things to have. I hope that you have a good grasp of times tables. That means that you're fluent with times tables and that you are good with mental arithmetic, the bond stuff that you should learn in foundation phase. And by now should be good, but it isn't always. So those things will really help you, and I'll explain why on the next slide. So this is why the prior knowledge is important. If you're doing multiplication like this, and you are, so in this way we would multiply those first, then those first, then those first, then those, then those, then those, and then we would add our two answers together. So we need to know our times tables, because 3 times 7, if you're sitting there going 7, 14, 21, then you're more focused on your times tables than you are on what's going on here. Whereas if I look at 7 times 3, it's 21. I don't have to work it out. I already know it. Having done times tables for so much of, for so long, it's one of those things. It's just in my head. I don't even bother to work it out. It's a fact. 6 times 3 is 18. 5 times 3 is, and you can see. And then the mental arithmetic, I'm talking about if we're adding these together. Okay, the first two are easy. 1 plus 0 is 1. 0 plus 8 is 8. But then, whoopsie, if we get to the next one, which is 7 plus 6, if you're sitting there going 8, 9, 10, 11, you might get distracted from the overall process of doing multiplication while you're focusing on the details. And that can lead you to either be slow or make a mistake in between, which that mistake will result in a wrong answer, but it might not actually demonstrate that you don't know how to do multiplication. So you might know the process but make a mistake because of your times tables not being strong. Okay, so if you are somebody who struggles with timetables, I would really suggest you spend some time learning those timetables now while you're still in early primary school or early in your school career, so that later on it doesn't slow you down. So you can daily just go through one of your times tables, something like that. Okay. We spoke about what I mentioned in the thing about wanting to make sure that you know the multiplicative properties of 0 and 1. Basically just that you know what happens when you times anything by 0, and you know what happens when you times anything by 1, which I'm sure both of you know both of those things already. But if you go 2 times 0, you get 0. If you go 1,000,000 times 0, you get 0. Basically, any number multiplied by 0 is 0. Okay. That's just something to bank in the back of your mind. I'm sure you knew that already. Next one, 5 times 1, 5. 5 times 765,001 is 765,001. In other words, anything multiplied by 1 is the number you started with. Oh, that's supposed to say 1 over there. Whoopsie, that's a mistake. So it should be 1 times 765,000. Please ignore that. Oh, even teachers make mistakes. All right. So let's have a look at the commutative property of multiplication. So both addition and multiplication have this property, is that we can actually switch things around and still get the same answer. So if we look at 4 times 5 is 20, 5 times 4 is 20, 15 times 3 is 45, and 3 times 15 is 45. So if one of those is easier for you to do than the other, you can switch them around and make your life easier. So you might think, oh, so what? But it does help when we've got maybe 3 numbers multiplied by each other, because we can change them in any order and we will still get the same answer. So if I look at the first one, which I've written down, which is 2 times 3 times 5, I can say 2 times 3 is 6, 6 times 5 is 30. But I might, if I prefer to do the 2 times the 5 first, 2 times 5 is 10, and 10 times 3 is super easy, is 30. Now, I've picked a relatively easy example, but sometimes with bigger numbers, switching them around really does speed up the process, especially if you're doing it in your head. Okay, I wanted to mention the tricks when we are multiplying with 0. So I've picked this over here. And not multiplying with 0, tricks when there are zeros in the numbers you're multiplying. So for example, 40 times 3 is 120. But I noticed that I had a 0 over here in one of my numbers I was multiplying, and I ended up with a 0 over there in what I was doing. So I could just start off by putting a 0 at the end, and then just multiplying the 2 significant numbers. So by significant numbers, I mean the 2 numbers that are not 0. So I could just say, well, if I get this problem, 40 times 3, I can say, well, 4 times 3 is 12, and then I can just move the 0 onto the end. So 40 times 3 is 120. It works with any multiplying when you've got zeros on the end. So if, for example, we've got 20 times 30, again, I can say 2 times 3 is 6, and then I've got 2 noughts that need to go onto the end over there. So my answer then for 20 times 30 is 600. All right, it's a useful trick to have. I'm not spending a lot of time on it. I hope that your teachers have practiced it with you. You are going to see there is something where we use it in multiplication. Actually, you use it anyway, probably, but you maybe didn't know you were using it. Okay, here's one of the methods we can use for multiplication. Multiplying, I don't know, I want to call it multiplying in parts. I don't use this. I'll explain why when I've done it, but it is good to practice. It helps with your use of numbers. So let's say we had 435 times 23. I could start off by looking at my 400 times the 20 from the 23. Then I'm going to go my 400 times the 3 from the 23. So I first did 400 times the 20, then 400 times the 3. Now I'm going to look at my 30, and I'm going to go 30 times the 20, and then I'm going to go 30 times the 3, and finally I'm going to go 5 times the 20, and then 5 times the 3. And once I've worked all of those out, I can then add them together. So 0 plus 0 plus 0 plus 0 plus 0 plus 5 is 5. 0 plus 0 plus 0 plus 9 plus 1 is 10, so 0 carry 1. That 1 is in my head, plus 2 is 3, plus 6 is 9, plus 1 is 10, 0 carry 1. 1 plus 8 plus 1 is 10, 0 carry 1, and my answer is 10,005. So it's a nice way when you're learning to multiply, where you multiply each of the pieces out like that. The reason it's not my favorite method is because I sometimes see children miss out on one of the things they had to do. Or if you make a mistake in any one of these with your answer, or if you make a mistake adding up, you're going to end up with the wrong answer. So there's quite a few opportunities to make mistakes. The other reason I'm not a big fan of this is because it takes quite a lot of space. So we have 3 numbers and we have 2 numbers. 3 times 2 is 6. And you'll see there's 6 lines over here. It's actually also a good way to check that you didn't miss anything, is check how many there are, times them together, and that'll tell you how many rows you should have. So 3 digits in my first number, 2 digits in my second. 3 times 2 is 6. I should have 6 lines working out. Okay, so that's one of the methods. I'm going to pick the same sum. This is the column multiplication. It's my preferred method. I know that a lot of teachers prefer this one as well. It's perhaps, I don't know, it's most straightforward for me. Some people call it the turtle head method. I've heard it called other things as well. All right, so we're going to lay out our problem like this time. So I've put my numbers underneath each other, making sure that we line them up on the right-hand side. All right, so I'm also lining up my units with units and tens with tens, but making sure it lines up on the right-hand side. Okay, so we're first going to start by multiplying 3 by that. So I'm actually initially going to ignore the 20, and I'm just going to say 3 times 435. And when I'm done with that, I'm then going to say 20 times 435, and I'm going to put those two underneath, and then I'm going to add them together. So that's what you are doing when you do this method. So we're going to start off by doing our 435 times 3, this one. So I go 3 times 5 is 15. I put my 5 there, and imagine I've carried my 1 over to the 3 here. 3 times 3 is 9, plus the 1 that I carried is 10. I put my 0 there and carry a 1 across to here. It'll be easier on the whiteboard when you can see me carry. Then I'm going to go 3 times 4, which is 12, plus the 1 is 13, and I bring it down. There's nothing more to carry to, so there's my 1,305, which is 435 times 3. Now, this is where our trick with 0 comes in. So this over here, we're about to multiply 435 by 20. But if you remember, 20's got the 0 on the end, which means I can use that trick where I just put the 0 at the end. And in fact, that's what we do when we put this 0 here. So lots of teachers teach you to put the 0 there, but not everyone tells you why. Why is it that you're putting a 0 there? It's because actually this is not 2, this is 20. So I'm going to put my 0 there. And now that I've put my 0 there, I can actually just multiply as though this was 2. Right, so I go 2 times 5 is 10. So there would be a 0 that I'll put over here, and I'll carry 1 to my next column. 2 times 3 is 6, plus 1 is 7, so the 7 will come under the 3. 2 times 4 is 8, and 8 will come under the 1. There we go. So, slightly squiff, but it's close enough. All right, so that was B doing 435 times 2. I've got the 0 trick for the 0 at the end. My next step is to add the 2 together. 5 plus 0 is 5, 0 plus 0 is 0, 3 plus 7 is 10, carry 1, 1 plus 1 plus 2, 8 is 10, and there's our answer, which we already knew from the previous page. Okay, I think it's time to switch across to the whiteboard so that we can practice a little bit more. Make sure I'm over there. Okay, I've got some word problems down at the bottom, but before we get on to some word problems, let's maybe just do a couple of examples where we work through with the carrying. So you might get single-digit multiplication, or 2 times 1, or 2 times 2. I'll start with a couple of examples like that. They follow the same pattern. All right, so let's start with 29 times by 8. Oops, I'm a little bit off screen. 29 times by 8. All right, so in this one, see if I can get a straighter line than that. Oh, that's a bit better. In this one, because I only have 1 digit, I'm only multiplying by 1 digit, I'm actually only going to have 1 row. So, hoping your times tables are good. 8 times 8 times 9, 72. And I'm going to carry my 7 to above the 2 over there. All right, then I'm going to go 8 times 2, which is 16, and then I'm going to add my 7, so 18. Good if you've got mental arithmetic. Comes to 25. My 5 goes there. I could carry it up to there, but there's nothing to multiply with, so it just drops straight down. And there we go. All right. No, it's not 25. It's 23. Oh, shouldn't talk and do it at the same time. Yeah, so 8 times 2 is 16, and then we've got to 23. All right, so that's my final answer over there. I'm now going to do one where we're multiplying 2 digits by 2 digits. So let's take 67 times by 24. All right, now because this one has 2 digits, I'm going to end up with 2 rows. Later on, when you practiced with this, I actually prefer my students to lay everything out before they even start, just so that they don't accidentally miss putting the 0 in when they get there. Right, but yeah, so that's fine. We may as well just put it out like that now. Okay, so I'm going to start off with doing 7 times 4, which if your times tables are decent is 28. Carry my 2. Next I'm going to do 4 times 6. 4 times 6 is 24. 25, 26. We added the 2. There is my 26. Okay, I'm actually done with these numbers up top, and if you want not to get confused, because I might have to carry in the next line as well, you can either cross them out or erase them. I'm going to erase those lines as well. Okay, so now I'm dealing with the 2. I'm going to say 2 times 7 is 14. There's my 4. Carry my 1. That's why you might get confused in the second row, because you've got another, you already had a digit to be like, oh, what am I supposed to add? The 1 or the 2? I'm not sure. Okay, so then we're going to go 2 times 6 is 12 plus 1, 13. Now we need to add them together. 8 plus 0 is 8. 6 plus 4 is 10. Carry my 1. Together comes to 6. And 1,608 is my final answer. Okay, let's do another one. This time we're going to do 3 digits by 2 digits. So let's say 128 times by 43. If you have a quad book is one of the books which has the squares in it. Please make sure to use those squares. Keep it to 1 number per block. It's really good to help you line things up so that things don't become squiff. Make sure that you don't miss anything by mistake. Okay, first up I'm doing 8 times 3, 24, carry the 2. Next I'm just going to put this upright so I'm not looking quite as far down from the screen. And I'm going to do 2 times 3, which is 6, plus the 2 is 8. 3 times 1, so I'm doing that one. 3 times 1 is 3. All right, I'm going to erase my 2 or cross it out. I'm going to take those marks out. I'm just showing you what I was doing, so I'm not going to super pencil. Okay, next up we're going to do my 4 times 8, 32. 4 times 2 is 8, 9, 10, 11. Put my 1 there, carry my 1. 4 times 1 is 4, plus 1 is 5. Now we add. 2 plus 8 is 10, carry 1. 5, 5. Right, you can see already as I'm going why it's quite important to be good at your times table so that you don't spend the time in between getting lost and having to sit there and work out your times tables as you go. And likewise with your mental arithmetic. Okay, I'm going to do mostly 3-digit by 2-digit, but I am going to show you what would happen when you're doing a 3-digit by a 3-digit. You don't do that in grade 5, although unless you have a teacher who wants to stretch you. But it's good. It follows the same pattern. So I will demonstrate one and then leave it. Don't let it confuse you if you're worried about it. But it is nice to know that you can do it with bigger numbers as well. So let's have 245 times by 124 All right, I would lay that out 245, 124, exactly the same as we've done it before. All right, now previously when we multiplied, we first multiplied by the units, then by the tens. So that's basically, we're going to start off by multiplying by the 4. So we're going to do 245 times 4 in this row. In the next row, we're going to be looking at 245 times by 20. And in the next row, we're going to be looking at 245 times by 100. All right, so if you were following the logic, then you would notice that in the first row we will... Okay, let me work it out as we go. So 4 times 5 is 20, carry 2. 4 times 4 is 16, plus 2 is 18. 4 times 2 is 8, plus 1 is 9. All right, so that's my... Oopsie. That's my first one. That's where I did 4 times 245. Now for the next one, I'm going to have a 0. In fact, I normally do this thing to make sure it's the right 0, and I put a smiley face in it. I call it smiley multiplication, but you can call it, you don't have to call it that. All right, so then I'm going to go 2 times 5 is 10, carry 1. Oops, that's a funny one. 2 times 4 is 8, plus 1 is 9. 2 times 2 is 4. Erase my marks. Whoops. Not doing... Oh, there we go. Okay, now in my next one, I had 2 zeros from the 100, and so I'm going to do that trick with zeros, but I've got 2 zeros over there. And now we follow the same pattern as we've gone. 1 times 5 is 5, 1 times 4 is 4, 1 times 2 is 2. And we add them together. 0, 8, 18, 23, carry 2, 10, carry 1, and there's our answer. All right, so that's how you do it with 3, and likewise if you did it with 4, you'd have an extra row, and the next row would have 3 smiley faces in it. All right, so it follows that kind of logic and that kind of pattern, but you're not expected to be able to do that this year. Okay, a couple of tricks to watch out for. Let's say we had 345 multiplied by 22. So the reason I'm picking this one is because 22 is a repeated character. So I'm going to now lay it out. 2 times 5 is 10. Carry 1. 2 times 4 is 8, plus 1 is 9. 2 times 3 is 6. 2 times 5 is 10. 2 times 4 is 8. Sorry, I didn't carry my 1. 2 times 4 is 8, plus 1 is 9. 2 times 3 is 6. So, I wonder how many of you noticed that these two numbers are the same, but with an extra 0 in place. And that will happen when you've got repeated digits over here. So that's a useful thing to remember. I'm not even going to bother working out the answer because it's not really important to what I was showing you. The next thing I wanted to show you is actually evident in this one over here. So you'll notice we had a 1 over here and we got 245. That's the multiplicative property of 1 because 1 times anything is itself. So if you have a 1 there, you can basically just put your digits in order as they appear in their first number. Neat trick, saves some time. All right, that's a good start. I think it's about time for a Nomu hot chocolate break. I'm going to do that again. Let's be honest, studying sucks. But here at Worksheet Cloud, we make it suck way less. In Worksheet Cloud, you can earn avatars, sidekicks, collectible coins, and then level up all while studying. Plus, we've just added our most exciting feature to date, the brand new Worksheet Cloud Rewards Hub. With Worksheet Cloud Rewards Hub, you can earn epic rewards and unlock entry tickets to win real giveaway prizes, including a Sony PlayStation 5, some yummy Nomu hot chocolate, and some fresh Worksheet Cloud merch. The more questions you answer, the more points you earn, and the more rewards you unlock. Worksheet Cloud makes your studying easier with video lessons, practice exams, practice questions, and study notes. In other words, we're your go-to place for all your studying. Ask your parents to sign you up at worksheetcloud.com today. Right. I think it's time we go and have a look at... Oh, hello, Dash. Did you get excited because I was sipping my hot chocolate? No, good boy. Okay, I think it's about time we have a look at some word problems and work out the maths from the word problem. So first up, whenever we get a word problem, there's a couple of things we have to have. We have to have a number sentence, we have to show our workings, and then our answer has to be in a word sentence. It's kind of a really good rule to get into it, and some teachers will dock you lots of marks if you miss one of those steps. Even if your answer is right, they might just give you a part of the marks instead of all of it because you have failed to do those three things. All right, so Saville runs 24 kilometers a week. If he doesn't miss a week all year, how far will he run? So there's maybe a little bit of a sneaky thing in there, but you should know this by now, is I didn't tell you how many weeks there are in a year. But you should by now know that there are 52 weeks in a year. Okay, so we've got two pieces of information. We've got 24 kilometers, that's how many he runs a week, and we have 52 weeks. So that's our number sentence, and we start off by writing a number sentence. Later on, when you get to high school, you'll write your number sentence, or even grade 7, you'll write your number sentences like that, and you'll say that that times that equals x. Ooh, but just x represents the answer we haven't got yet. That's algebra. Okay, so now that we've got it, let's lay it out correctly. So I prefer to write it underneath each other. So 52. Again, if you prefer to put the bigger number on top, because of the property where you can change the order, the commutative property of multiplication, you could have put it the other way around and it would still give you the same answer. So whichever way makes you more comfortable. All right, laying it out nicely before we start. Put my smiley, my smiley face down there. All right, and 2 times 4 is 8. 2 times 2 is 4. Oh, I'm really going to have to zoom in to do this. Oh, come on. There we go. Okay, 48. Next row. 5 times 4 is 20. Carry my 2. 5 times 2 is 10. 0, 1. Now I'm going to add them together. 8 plus 0 is 8. 4 plus 0 is 4. And my final answer, 1048. So Saville runs 1,048 kilometers in the year. And we need to make sure to write that in words. Saville runs 1,048 kilometers in a year. Or in the year, whatever you want to write. Okay, so there we go. There's our first word problem. Let's have a look at our next one. Actually, I'm going to swap these around. Sibulele. If you ever wonder, teachers often struggle to come up with names, so we kind of like pick a theme for a day. So the first two names, Saville and Sibulele, are actually rangers for sandparks who operate in the Constantia Neck area. But there we go. Randomly, teachers sometimes struggle. Sometimes we use past people's names, sometimes my dogs, sometimes my niece and nephew, sometimes colleagues, but we have all sorts of different ways of finding names to put into our word problems. Okay, so Sibulele is an excellent cricket player. He's scored 9 half centuries and 4 centuries this season for his team. From these 13 innings, how many runs has he made? So he might have had other innings, but we're only looking at those particular ones. All right, it does require you to know what the word century means. And I do throw these things in because sometimes maybe you'll learn it from today. Otherwise, maybe it's something that you know already. Okay, so a century in cricket, or a century is 100 years, or in cricket it's 100 runs, and a half century is half of that, which is 50. All right, so what we've got over here is we've got 9 half centuries. So he's got 9 times 50. All right, and then 4 centuries plus 4 times 100. There's our number sentence. So I have thrown in a plus over here, but I think it's okay. Now, I'm not going to, you can lay it out how we did it before, but this one lends itself really nicely to the tricks with 0. So if I'm looking at this part first, I'm going to say, well, I'm going to go right ahead and put the 0 down there. Now I can kind of ignore it while I do my maths. So 9 times 5 is 45, which means that 9 times 50 is 450. I'll leave my plus in place. Now I'm going to do this one. Again, I noticed the 2 zeros over there. I'm going to go put those down there using my tricks with 0. And now I've got 4 times 1, which is 4. So that's 400. All right, which means I've now just got to add 400 and 450, which gives me 850. But we are not complete because we haven't written a word sentence. Sibulele scored 850 runs in the 13 innings. Innings is a turn to bat. All right, next one. I've made some of these problems a little bit more complicated, but not super complicated. And that's because often that is the hardest part of maths, is to figure out what you're supposed to do with the words that you get in your word problems. A courier company does 16 trips to Tilbach over the course of a year. They drive the distance twice each time as they need to return to their starting point. So if you're delivering something to Tilbach, you can't drive to Tilbach and then stay there. You've got to come back to where you started. So although there were 16 trips, how many times did they drive the distance? Well, it would be 2 times that because it's there and back. And then if the distance is 119, that's to Tilbach, which it actually is. I looked on Google Maps. How far do they drive on this route in total? All right, so we've got a few different things in there. First off, we've got 16 trips, but then we've got that they're doing twice. So it's 16 trips times 2. And now we need to work out how far it is, and we've got 119, so it's 119. Okay, so it's 16 times 2 times 119 equals, and that's what we're looking for. So the first thing I would do is that. I would just get that out the way. Let me show you how I would do this in my head. I'd first say 2 times 6 is 12. Keep that in my head. So I've got 12 in my head, and then 2 times 1 is 2. So I then so that's 20 because it's actually got a placeholder there. Putting those together, I get 32. All right, so I'm looking at 32 times 119. Okay, I'll just shift this a little bit up and shift that a little bit down. Okay, so I've got 119 times 32. All right, ready to go. 2 times 9 is 18, carry the 1. 2 times 1 is 2 plus 1 is 3. 2 times 1 is 2. Next line, okay, so I'm going to raise my mark. The next line, I'm going 3 times 9 is 27. Carry 2. 3 times 1 is 3 plus 2 is 5. And 3 times 1 is 3. Now we bring them back together. 8, 10, carry 1, 8, and 3. So they drive 3,808. I am not finished. I have to write that in a sentence. They drive 3,808 kilometers on that route. Right, and there we go. Some teachers will even actually give you marks if you got your answer wrong, but then you turned your answer into a word sentence like this. They might even give you a half mark just for having done the right thing in terms of putting it into a word sentence. So even if you're not 100% sure of your answer, make sure you do. Okay. Ndima only reads books that are exactly 345 pages long because maths teachers need to make up word problems and sometimes they don't have realistic ideas, like right now when I made this one up. So I don't know why. It makes no sense in real life. Why would you only read books that have 345 pages? But that's the sum. All right, she read 18 books this year. How many pages has she read? So it's a straightforward multiplication one. We just need to make sure that we're multiplying 345 by 18. Let's write our number sentence. 345 times 18. We can put it into the format we want. Okay. 5 times 8 is 40, carry 4. 8 times 4 is 32, plus 4 is 36. And 8 times 3 is 24, plus 3 is 27. Okay, so you'll see that because my times tables are fairly good, I don't spend much time working that out in between. So the more you practice your times tables, actually the easier big multiplication is, long multiplication. All right, using that trick, because I'm using a 1 over here, I actually know that my answer is going to just be itself. So we've got 5, 4, 3, 345. We're going to put those together again. 0 plus 0 is 0. 6 plus 5 is 11, carry 1. 1 plus 7 is 8, plus 4 is 12, carry the 1. 6. So the answer then is 6,210. So Ndima read 6,210 pages in the year. Okay, Ndima is one of my students actually at the moment. I'm sure she'd be thrilled if she knew she was in this video, but she's not in grade 5, so she won't watch it. Okay. Gavin pays a monthly amount of $422 to Deep Blue Security for armed response. He wants to ask them if they will give him a special rate if he pays it all together at the start of the year instead of monthly. He needs to know what he pays in total when he pays each month. So this is a very long-winded story. I don't know if you know, but sometimes if you pay something all at once, you get a discount. And that's what Gavin's going to ask. So he's going to say, if I pay it all at once, can I get it for a lower rate instead of if I pay it monthly? Just because I think that maths fits into life so much, I'm going to tell you why they do something like that. So if Gavin gives Deep Blue Security that money altogether at the start of the year, Deep Blue Security can do something like either they can invest it, put it in a bank and the bank gives them interest, so they earn money on that, or they might be able to do some expansion that will then result in them being able to earn more money. And that's why companies do sometimes offer you a discount if you pay a lump sum all at once at the beginning rather than paying it off monthly. So that's why this kind of thing would work. But anyway, back to the maths. So Gavin pays 422, and basically in a very long-winded way, they want to know how much does he pay in a year. So they've relied on the fact that you know there are 12 months in the year. If you don't, perhaps you should be watching the grade 4 videos. Okay, so our number sentence will be 422 times by 12 equals, and let's put that into our form, 422 times 12. Oops, 0 over there. And let's get started. So 2 times 2 is 4, 2 times 2 is 4, 2 times 4 is 8. Oh, and we've got a 1 again. So it's going to be the same number, but 2, 2, 4. And if we add them together, we get 4, 6, 10, carry 1, and 5. 5,064. But we're not finished because you must remember to put down the number sense on. Oh, actually, let me put that in there. 5064. And we've got to say he currently pays $5,064 per year. So now that Gavin knows how much he's paying for the whole year, he can go to Deep Blue and say, well, if I paid you monthly, you'd get 5,064 Rand. But maybe if you accept a lump sum, what about if we do 4,500? So he needs to know where to start before he can ask questions. Okay. I think that's enough word problems today. Do know that we don't learn by watching, we learn by doing. Well, if you learned by watching, I think I'd be pretty good at cricket and tennis, but sadly, I'm only average, and that's because we learn by doing. So please click on the link that you can find below this video in the description, which will download a worksheet so that you can practice what it is that we've been learning about in this lesson. And don't forget to get your parents to sign you up for Worksheet Cloud so you can access all of their worksheets and memos, and more importantly, that rewards hub where you can earn cool rewards like merchandise from Worksheet Cloud or Nomu hot chocolate or even that PlayStation 5 if you're lucky. Have a great day, grade 5s. I'll see you soon for another maths lesson. Bye.